Hello everyone, welcome back to Fundamentals of Python Bootcamp. My name is Aman Saini and I'll be your instructor throughout the course. This is lecture number 19 and today we are going to learn about the different types of method we have in Python. Alright, let's jump to our Jupyter notebooks. Okay, so in Python, majorly there are three types of methods. First one is instance method, second one is static method, and the third one is class methods. Okay, in the last lecture we have learned about the different concepts of OOP and we have also understand what are decorators uh, as an introduction only. So now let's understand what are decorators in depth. Okay, not fully, just to understand the examples and the difference between these three methods. So it's very important to understand the design pattern, how decorator works. Okay, decorator sounds complex, but they are nothing to fear. Decorators are very simple functions. You can write them yourself or use them included in the library or Python standard library. So few decorators are already there in Python. So you can use them as well. Okay, like any functions, decorators also perform some tasks inside their body. So the difference here is that decorators apply logic or change the behavior of other functions. They are excellent way of using a or reusing a code and can help to separate logic for basically individuals concerned. It's up to you. Okay, let's understand decorator with an example. So let's say we have this function. We have decorator function, which is an outside function. It takes an argument, which is also a function. And inside this function, decorator function, what we are doing, we have defined an internal function. In our case, we call it as a wrapper function. So this, what it will do, it just print out a new message and it calls out the original function. Okay, and in return, what are we doing? We are just returning the wrapper function, which is not called yet. It is just waiting for to get called. Okay, and after that, okay, let's comment out this particular line, and then let's do display name. Okay, we have defined two different functions, and then we are calling display name. Okay, before this, let me split out the cells and then only define the function. So now we have two functions, display name and decorator function. So if we call display name, it just say hello Ram, and that's expected. Print hello Ram. So let's say whatever this function is doing, we want to add some more functionality. What we have to do is we need to print just a simple message. This decorator function is called, or maybe we want a message. Let's say. Um, Welcome on board to microbiology department. Okay, and then we just say hello Ram. Welcome on board to microbiology department, and then hello Ram. We just want this thing, and whatever the name in this, whatever the thing this function is doing. Before that, we want one additional message, and that is this. So we have done this kind of thing, and it's totally very obvious that this function is going to take something, and then we are doing some operation, and we have successfully added a new print statement as well, whatever we wanted. So if we just want to change the definition of this display function with this all functionality, what we have to do is display name equals to decorator function and then passing display name. So what we are doing, we are passing this function into this decorator function, and whatever this decoration function is returning, we are assigning it back to the display name. So now we have changed the functionality of this display name. So let's say if we call this display name, so what it will do, it will print the additional message as well as the original function. Okay, so now you will ask me like, sir, the definition of display name is changed, which means the original code is also changed. So what makes sense? We can directly update this function as well, right? So it's not recommended to use the original name. So what you can do is, let's define these two functions again, and then whatever we are doing, that is display microbiology department. Let's say display micro. This is our new function. So we can use this function now. So it will do, oh, I'm sorry, execute this. And then what we will do, we will have this function, new function, which has all the functionality of this function, as well as it has the additional functionality as well. So that's how we can use decorator. So what exactly it is, we can change the functionality. So let's say we have this, and this exactly statement we have, yeah, this one. So whatever is written here is exactly same like this. So decorator function, whatever we are defining this function, we can use it, and decorator function we can do. So just define it. So now we don't need to execute this thing. We can directly say display name, and then we have the same thing. Okay, so what we have did, we have added this functionality to this function directly using a decorator. Alright, so another example we have, so we have a decorator example class. We have a constructor. In this constructor, just we are doing hello world. We have used a static method uh, decorator, and then we are defining example function, and what we are doing, I am a decorator function. So yes, exactly, so this example function is now a decorator function. After this, we are just creating an instance of this class, and then we are just calling out this example underscore function method. So what it is doing, it's just printing hello world, and I'm a decorator function. So constructor is called first, and then we are just doing I'm a decorator function print. Cool, makes sense. Alright, so decorators have the immediate precede a function or class decorator. They are started with @sign, and unlike normal methods, you don't have to put parentheses on the end unless you are passing in arguments. Okay, like you see, this is the decorator function, and we haven't passed any parentheses here. So we can use parentheses only when we are passing the parameters or arguments inside this function. Okay, it is possible to combine multiple decorators as well, write your own or apply them to class or whatever you want to do. Okay, let's understand instant message now using decorators and all. Okay, instance methods are the most common type of method in Python classes. So they are so called because they can access unique data of their instance. So in this case, this is the instance of this class. So this instance can have different properties and different values for every uh, property of the class, attribute basically. If you have two objects, each created for a car class, let's say, they can have many. They each have may have different properties. For example, they have different color, different engine, different seats, and so on. So instance method have self as a parameter. So I'll show you what is self, and I guess we have already understand what is a self in our previous classes. So then they each have the different properties. They may have different. Okay, I have explained this thing. So self is another Python special term we have understand. Inside any instance method, you can use self to access any data or method that may reside in your class. You don't need to be able to access them without going through the self keyword, as we already know. Okay, finally let's understand instance method with an example. And one more thing, you don't need decorator to define any instance method. You can directly define it. So as we have this class decorator example, we have a constructor, and then we have this function instance function, sorry, example function, and then what we are doing, we are just printing out the name. My name is this. Okay, and then we are creating an instance de, decorator example and de dot example function. We're just calling it. I'll change it more. Let's say we are passing value name, and what we are doing, self dot name equals to name, and then inside this, whenever we are creating an instance, let's say this this is an instance for Indian, we are passing the name, let's say Ram, and then we are doing Indian dot example function. So it will do, okay, I have to pass two things. Decorator example, I have passed Ram. Okay, I have to execute this first. Okay, sorry. So Indian equals to decorator example, and then we are passing the name, and then we are just calling out. So what it is, it has a property which is name, and here in this instance Indian, the property is Ram. So let's say we have another instance, let's say it will be British, and we are passing the name John, let's say, and then we are doing British dot example function, and it will say this particular function, this particular variable name is having a value of John. So which means an instance method can access different values. So this example function is having name value as John, and this particular example function is having name as Ram. So instance method is clear, and you have to pass on self, and you can have different properties. So this is exactly an instance function. Okay, what are static methods in Python? So static methods are methods that are related to class in some way, but don't need to access any specific data that is related to the class. You don't have to use self, and you don't need to instantiate an instance. You can simply call your method. So nothing is needed for this static methods. You can directly define it. Everything is belongs to static method, will be reside inside, and it can't access anything from the class. Okay, in this case we are just doing decorator example. We have init, we are printing hello world, we have static method which is example function, and is also doing print. Makes sense. And here what we are doing, we are just creating an instance and then calling out the function. So we can directly call the static function of a class. Got it? And then once the static function is called, we can also assign it to the instance. Okay, so that's how we can do it. Let's say we have an property name equals to class. We have this variable, and let's say we want to access this name inside the static function. Name equals to, okay, let's print it, name, and then just call it. So it will throw us an error that is name is not defined inside this function. So you can see in this error, at this stage name, print name, we are just printing out the name. It is showing that name is not defined, which means this name is out of the scope of this class. Oh, sorry, this name is out of the scope in this function, and you can see this function is defined inside the scope of this particular class, but still we are not able to use it because it is a static method. Cool, makes sense. So I'm defining it back to the original definition and then execute it. So the at the rate static decorator was the main thing to define this function as a static method. Okay, so static method are great for utility functions which performs a task in isolation. They don't need and cannot even access that class data. They should be completely self-contained and only work with the data passed in as an argument only. You may use a static method to add two numbers together or just printing any string. So this is where you can use a static method. Okay, now let's jump to the class methods in Python. So class method are the third and the final oops concept of method, and it is the very complex one. So class method, also known as their classes, they can't access specific instance data, but they can call other static methods. So additional to this, we can only do thing is calling any particular static method of the class. Okay, so class method don't need self as an argument. So inside a class, like we pass self for this instance method, class method also don't need self, but they do need a parameter called CLS. Instead of self, we need to pass CLS as a parameter. So this stands for class, and like self gets automatically called by a Python. So class method also used by @class method decorator. So to define any class method, we need to use this decorator. So in this example, we have a constructor. We have this class method which is named as example function, and we have a static method which is some another function. Okay, so here what we can do is, so you can just see we have used CLS as a parameter for this class method, and here we're defining the instance, and then we are calling de.example function. Okay, so see the output. So we are getting hello as well, but we have called only example function. So why so? Because inside this class method we have called some another function which is a static method. And how we can do it? We can access using the CLS argument we have passed. So using the CLS we can access any static method defined inside this class. So that's how and where we can use class method. So class method are possibly the most confusing method, as I told you, but they have their own usage. So class method can manipulate the class itself. So like we manipulate any method using decorator, we can manipulate any class using class method, which is useful when you're working on a very large or complex project. Okay, let's go with the summary whatever we have learned till far. So instance method, the most common method type able to access data and properties unique to each instance. So that's exactly as an instance method. Static method cannot access anything else in the class. They totally are self-contained. Okay, class methods, they can access limited methods in class, meaning they can access static method of class, can modify class specific details. So that's how what all these methods are being defined and how they are used. Alright, so if you guys have any question related to these, you can just point out your queries into the forum. I'll be there to help you. Thank you so much.